today's video is going to be all about measuring segments. So let's remember what a segment is. It's a piece of a line. Whoa. Sorry about my handwriting. With two endpoints. So there's an example. Just basic and simple. Okay? So the first big thing for today is this ruler postulate. So the points of a line can be put into one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. That's a lot of stuff. Okay, so here's what it means like in easy talk. Let's say you got a number line here. Here's 0. And you have a point A down here and a point B down here. Okay? So it's saying, and let's find out where A is at. Well, A is at 1, 2. It's backwards, so it's at -3. B is at 1, 2, 3, 5. And we could do the absolute value, absolute value of -3 minus 5, which is -8, which we all know is 8. That's basically what that means. Okay? And then something hugely important is that if two segments have the same length, we call those congruent. This is like one of the biggest, most important words in geometry. We're probably going to use it all the time. I don't know if you can see that symbol right there, but basically it's an equal sign with a squiggle on top. We're going to use that so much in this class, so just get used to using it. Alright, let's use this ruler postulate thing. So we got us a number line here and a few points thrown on there, and wants us to find A, B, and B, C. Now I want you to notice something. Earlier in our lessons, we've talked a lot about making sure to use the bar on top to know it's a segment. This is the name of the segment. Okay, we call it segment AB. Right here, because there's no symbol, this means find its length. Okay? So we're going to go from A to B, find out how long it is. Absolute value. A is at -8. B is at -5. So remember, we subtract a -5. Minus minus makes plus. So that's going to be -3, which is 3. Now let's do B to C. B is at -5 minus -2. Okay, so that's how AB is 3 and BC is 3. Now, next question. Are AB and BC congruent? Remember, what's it mean to be congruent? It means they are exactly the same. They are the same, so we would say, yes, they are congruent. Okay? Let's look at C, D, and DE now. Now, on this first example here, I use the actual ruler postulate to show you how it works. But you're probably thinking, can I just count on this number line how far it is from C to D and D to E? And of course you can, especially when you actually have the number line. Okay? So let's look at CD. 1, 2. Boom, there you go, it's 2. D to E, 1, 2. Are they congruent? Yes. Okay, that's the ruler postulate. You can either do the actual absolute value stuff, or you can do counting if you have the number line. Alright, next big thing is this segment addition postulate. This is kind of really important, but it's kind of common sense when you sit and think about it. So here's what it says. If 3 points A, B, and C are collinear, remember collinear means we're on the same line, and B is between A and C, then AB plus BC equals AC. So here's what I think in my head when I think of this. I've got a segment, and then there's 3 parts. You have a piece, you have a piece, then you have the whole. So you can think of it this way with B in the middle, AB plus BC equals AC, or you can say piece that's what you need to think in your mind when you approach a segment addition, a postulate problem. Piece plus piece equals whole. Okay, now let's use it. If RS equals 15 and ST equals 9, then RT equals what? So notice there's no bars. We're talking about actual lengths here again. And I'm going to do something that I highly encourage you to do when you do these kind of problems. If they give you a picture and some information, label the picture. It's going to help you to try and solve the problem every time. Okay? So, and make sure you label it correctly. So R to S is 15. So R to S is 15. ST is 9. ST is 9. We want RT. So RT would be our whole. So we would say RS plus ST equals RT. Plug in what you know from the picture. Well, we know RS is 15 plus 9 RT. And if we do a little math, RT is 24. Super simple. Okay, let's try this next problem. Let me erase what we've got here first. I want to erase this. Okay, now ST is 15 and RT is 40 RS. So make sure we read this carefully when we label, okay? ST is 15. So S to T is going to be 15. RT. What's RT? RT is the whole thing. We want RS. Well, again, RS plus ST equals RT. Plug in what you know. You can do it kind of like a little equation, subtract. If I can do math right, that's 25. Okay? So now, remember, this one asked for the whole, whereas this one asked for a piece. The problem changes every time. You have to just be careful and read what they want you to do. Okay. Now we're going to step it up a little bit and do some algebra. That's not that much harder, but just gotta be careful. So still doing segment addition, and we're going to stick with our notion of RS plus ST equals RT. Okay? RS is 3x plus 1, so I'm going to label that. ST is 2x minus 2. And then RT, now this time they told me the whole thing because I need it because I got variables. The whole thing is 64. So we're just going to plug in what we know. Let me label that the whole thing is 64. So I'm going to make my equation. RS is 3x plus 1. ST is 2x minus 2. And we equal 64. Now we're going to revert back to Algebra 1 and solve an equation. Combine like terms. Those are friends. 1 minus 2 is minus 1. Now, I'm going to start moving stuff, so if I have subtract 1, I'm going to have to add 1 to make it go away. Divide 5. X equals 13. So now we know what X is. I don't know what's wrong with my pen. I think my board's having a weird time or whatever. Anyway, now that's just finding the variable. Note what part B asks us to do. It wants RS and ST. Well, note that both of those have the variable in them, so we're going to take what we got and plug it in. Alright, let me get rid of all this first. Okay, so RS was the 3x plus 1, so we're going to take 3x plus 1, plug that in. 3 times 13 is 39, plus 1 is 40. ST was 2x minus 2. 2 times 13 minus 2. 2 times 13 is 26. Subtract 2 is 24. So this is RS and this is ST. Now, how do we know we're right on our answers? Well, remember, whatever we got for RS and add it with what we get for ST should equal RT. RT is 64. What's 40 plus 24? 64. So we know we did it right. Okay. Now we're going to do this again, but we stepped it up just a little bit more, a little bit harder. Now, I don't see a picture anywhere that they gave me. What am I going to do? I'm going to make my own picture. Doesn't necessarily have to, it can be whatever you want. Just notice that S is going to be in the middle. So I'm just going to do whatever, just something like that. Now I'm going to label RS. I need to change. Let's do this. So 8y plus 4, 4y plus 8, and then R to T, the whole thing is going to be 15y minus 9. So let's set up our equation. We're going to take the RT part, so 8y plus 4, add the ST part, so plus 4y plus 8, equal it to the entire thing, 15y minus 9. Now, this equation is a little bit more because first you have to combine the like terms on this left side, and then we're going to have variables on both sides, and we'll do that in just a second. But it shouldn't be too much harder. Alright, I'm going to combine some terms. 8y and 4y makes 12y. 4 and 8 is also 12 again. Okay, so now I got to figure out where I'm going to move stuff. And I'm going to think smart about this from just me personally, okay? I'm going to think ahead a little bit. I like to keep my variable positive whenever I can, okay? So, if I move 15y over here, that means I would subtract 15y. Let me just go show you. 12 minus 15 is negative 3y. That's going to leave my y negative, and I personally don't like that. So what I'm going to do is I'm not going to do that step. I'm going to move the 12y first. $15 minus 12 gave me 3y. Now, because I moved the y over here, this means I have to move this negative 9 over. It's negative, so I'm going to add. That's 21. I have a 3 in front being multiplied, so I divide 3. So 7 equals y. Or y equals 7. Okay? That's the first part. Now, look at the second part. It wants RS, ST, and RT. So, what now we got for y, we're going to plug it back into everything. So I'm going to clean my screen up a little bit. Okay? And now, notice every piece of this has that variable, so I'm going to have to plug it into everybody. RS was 8y plus 4. So 8 times 7 plus 4. 8 times 7 is 56. 56 plus 4 is 60. Now let's do the second part. ST was 4y plus 8. So 4 times 7 plus 8. 4 times 7 is 28. 28 plus 8 is 36. Now the last piece, RT. 15y minus 9. 15 times 7 minus 9. Need to check what 15 times 7 is real quick, because I don't know in my head, even though I should. 105. Minus 9. 96. So, were we correct in our work? 60 plus 36 equals 96. Yes, we were correct. Alright. Now things change just a little bit. So used to, we would have a picture where S was somewhere in between R and T. Okay? Now, it's telling us that A is the midpoint. Now, if you stop and think about what that means, it's kind of common sense. This is the point directly in the middle of the segment, okay? The midpoint divides a segment into two congruent pieces. Okay, remember congruent means equal. So looking at this picture here, how do I know that these segments are congruent? Well, these little tick marks, I call them tick marks, whatever. These little tick marks, if you see those, they tell you that those pieces are congruent. So we could say XA is going to equal YA. Whatever we get for XA's length, YA is going to be the same thing. Okay? Now, question is, find XA. Well, what is XA? They tell us it's 3x, right? Well, right off the bat, just thinking about it, I don't know what XA would be, though. Because there's a variable there, it could be whatever. But if you remember, XA equals YA. Whatever this length is, that has to be the same thing. What I'm going to do is going to set both of those expressions equal to each other because they have to be the same. Okay? I'm going to solve this. I'm going to move the 5x over. That gives me negative 2x equals negative 6. Divide negative 2. Remember your signs, negative divide negative makes positive. So x is going to be 3. Okay? Now, it wants to know what AY, or I would say YA. Find YA and XY. Okay? Well, we found what x is going to be, and YA is 5x minus 6. Well, I have a variable, an answer for x. Let's just plug it in. So 5 times 3 minus 6. 5 times 3 is 15. 15 minus 6 is 9. YA is 9. Now, what's XY? XY is the entire segment. Okay, it's all length. And we just found what this part is. This part is 9. Okay, so question is, how much of XY is the segment YA? Well, because this is a midpoint, this is half. So if one half is 9, the other half has to be 9. So XY is 18. Okay? So that's midpoint. It's similar to the segment addition postulate. It's just you're guaranteed that the point in the middle, in between the two endpoints, is in the direct center. Alright? I think that's all I have. Let me see. Nope, one more. Let me see. Yeah, one more. One more example. Alright. So PT. We want to find PT. Well, okay, let's look. PT is half the segment. Do I know this is a midpoint? Yes, because I see congruent tick marks. Okay. PT is 5x plus 3. I'm going to come label. PT is 5x plus 3. TQ is 7x minus 9. Okay? So if I want to know how long PT is, I first have to find out what x is. So I'm going to come up here and make me an equation. 5x plus 3 equals 7x minus 9. I'm going to move the 5x first. Now I'm going to add 9. Whoa. Equals 2x, divide the 2, x equals 6. Okay? Now I know what x is, I'm going to go plug it in. 5 times 6 plus 3. 5 times 6 is 30. 30 add 3 is 33. Okay? Super simple. Now I'm going to erase my stuff so I can do this again. PT is 7x minus 24. And TQ is 6x minus 2. So again, I'm going to set them equal. I'm going to move 6x. 7 minus 6 is 1x. X equals 22. So I'm going to go plug x in. Let me do that real quick. 7 times 22 is 154. Subtract 24. It's 130. Alright. Okay, let me. Why did I have to? Okay, I think that's it. Okay, here's your homework problems. You are to do numbers 1 through 3, 4 and 5, 8 and 9, 10, 11 through 13. Alright, that's all there is to know about measuring segments.